Right, grade 10s. In our last video, we had a look at the straight line graph, y is equal to mx plus c, and we were very familiar with that because it's something we met, or we were introduced to the straight line graph in grade 9. But now we're moving on to a new section called the parabola, which is this quadratic graph. So anytime we see anything to the power of 2, then we know we're looking at a parabola. So let's take a closer look at exactly what this means. Now, the standard form of the equation of the parabola, so we saw already, straight line, y equals mx plus c. Every type of function has its own standard form. So the parabola's standard form is y is equal to ax squared plus q. And actually, as you move into grade 11 and 12, this standard form starts to adapt a little bit and becomes more and more complex. We build on our knowledge. Okay, but what we need to know for now is two important things. The first one is that this a value tells us something and this q value tells us something. So let's have a look. The a value is going to tell us about the shape of the graph that we are dealing with. So if you've got an a value that is positive, okay, remember in maths we like to write it like that, greater than 0 means positive. If you've got an a value, then you've got what us maths teachers affectionately call a smiley face parabola. Okay, that's actually called a minimum value parabola because its little turning point there at the bottom is the minimum value in the graph. Okay, if you've got a negative a value, so smaller than 0, then you guessed it, it's a sad face parabola, or fancy name for it, maximum value parabola. So that a is very important, whatever it is, sign-wise, it's going to help us decide whether we are looking at a happy or a sad curve. Okay, the other thing that you know, or that you may know about this a value, is that the bigger it is, the higher the smile goes. Okay, the closer the arms are together. So a bigger a value means your arms are very close together, but if you had an a value that was small, like let's say 0,1, you'd have a very spread out curve compared to a curve of like 10, which would be very tight. And then the other important thing here is this q value, and that refers to the y-intercept of the graph. Okay, so basically where this turning point meets your y-axis, that's what the q value is. Now if you look at this graph, or these little sketches that I've drawn, you'll see they cut the x-axis and the y-axis, and so those are called our intercepts. Okay, so in this case the y-intercept is relatively easy to get because we can actually read it from the graph. That's the q value. Okay, but we can, like with any y-intercept, we can let x equal 0 and we can calculate it. That is possible. And then to get an x-intercept, or in this case, because it's squared, there'll be 2, so x-intercepts, we let y equal 0. And then we solve. Okay, it's a quadratic equation, so remember that you need to factorize that in order to solve it. Okay, and then, very interesting, this type of graph has a turning point. Okay, and at grade 10 level, the turning point is always going to occur on the intercept of the y-axis. Okay, that's not always going to be the case, but we can learn it like that for this year, and then next year we can grow our knowledge a little bit. So the turning point occurs when x is equal to 0 and y is equal to whatever this q value is. If it's 22, then y will be equal to 22 over there at the turning point. Okay, and then domain and range. I always like to picture a graph when I'm talking about domain and range. Okay, domain, those are the x values for which the graph is defined. So if you look at a parabola, and if you were to follow it up, although you'd go very, very high up in both directions, but what you'd find is that it carries on forever in the x direction negatively and forever in the x direction positively. And so there are a couple of ways you could say that. You could either say x is an element from minus infinity up to infinity, or you could say x is an element of the real numbers. That's just one of the nice short ways of saying that it exists everywhere. Okay, another way you could do this is you could use inequality notation, so minus infinity and then you use the inequality sign, x, infinity. Really, you are welcome to use any of those three because they all mean the same thing. So go with the one that makes the most sense to you. Okay, the y value, or the range in this instance, is a little bit different because this graph, in terms of this happy one, doesn't exist beyond this point. So 0 and q, whatever that turning point is there, I'm just using q as a placeholder. But what we need to then say, if they asked us for the range of something like this, is that this graph runs the smallest y value, always give from smallest to biggest. The smallest y value is this one here at the turning point, and then it goes all the way up into infinity. So y is an element from the turning point, where it exists, up to infinity. Okay, so these brackets, because the graph is defined at the turning point, I'm allowed to use a square bracket. But because we don't know what infinity is, it's too big for us to define, we use a round bracket there. Okay, if we had a look at a maximum value parabola like this one here, this sad one, then the range is going to be slightly different. Okay, so let's just say that's the range for that one. Okay, the turning point is now the maximum here. So 0 and q are the coordinates of this turning point. Okay, so if we were to write down the range here, y is an element. Remember, it's always from smallest to biggest. So smallest is going all the way down to minus infinity. So minus infinity, and then up to the maximum point, which is the turning point. Okay, so the range looks different depending on the shape of your graph. But if you understand what domain and range is, then you can actually do it by looking at the graph. You can do it from a place of understanding rather than a place of just knowing a whole bunch of theory. Okay, let's have a look at some examples. So sketch the graph of f of x is equal to 2x squared minus 2. So straight away, I see this square, and I know that I'm dealing with a parabola. Okay, I also see that this 2 is positive, so I can tell you straight away this is going to be a happy parabola. Okay, it's going to be a smiling one because of the positive a value. Alright, it's important for me when I need to sketch functions that I have x-intercepts and y-intercepts. So I can see the shape, I know what type of graph I'm dealing with, but let's do some calculations so that we have enough information to draw it. So for the x-intercept, let's let y equal 0, and then we're going to solve. So 0 is equal to 2x squared minus 2. Okay, and now we want to factorize. Okay, the first thing we do in factorizing is always take out a common factor. That always needs to be step 1. So there's a 2 in both of these terms, so we can factor that out. Okay, 0 is equal to 2. And now I hope that you are spotting what I'm spotting. This is the difference of squares. X times x is x squared. 1 times 1 is 1. So that's going to be x and x, 1 and 1. And 1 is plus and 1 is minus. Now I'm ready to solve. Okay, what I can do is just divide both sides by this 2. Okay, we never divide by x because we're not sure. X might be equal to 0, and then I'm doing an undefined thing, which we don't want to do. But when we have constants like that, we can just divide by them. So now I can break it down into 2 sections. So either x plus 1 equals 0, or x minus 1 equals 0, and then we solve. So x equals minus 1, x equals 1. So I can then plot those 2 points, and I think what I'm going to do is I'm going to plot them a little bit wider. So I'm going to make this one here, and this minus 1 here on my x-axis. That means 2 will occur here, minus 2, 1, 2, minus 1, minus 2. Okay, there my axes are nicely labeled. Alright, so that's the x-intercept done and dusted. The y-intercept, that's when we let x equal 0, or in this case we can actually just read it from the equation. But let's do both just to make sure. So we can read it and say, oh, it's probably going to end up being minus 2. But let's test. So we've got y is equal to 2 times 0 squared minus 2, which does equal minus 2. So there's our y value. Okay, and we already said we want to see a happy parabola. So now we've got those 3 intercepts. Let's sketch. Okay, and I always use that word sketch with a bit of caution because it's mathematics. So we need to be accurate. And we don't want to have a whole bunch of sketchy lines. Like that's not what we're doing. We can't draw that, but we do need to draw as accurately as possible. This is the graph F, and then you just check, have I labeled all these points? If you haven't labeled your axes, then you literally need to come here and you need to write down these points: -1 and 0, 1 and 0, 0 and -2. Okay, but if you label your axes, then generally that counts as a labeled intercept. Here's another one for us to sketch, just to check our understanding. Okay, so what do? We first of all just analyze, and we say it's negative, so it's going to be sad. It's a third, so it's going to be more spread out than some of our other ones that we've drawn up until now. Okay, and then x squared, and then the q value, which I don't see there, is going to be my y-intercept. So if there's nothing written down, I can tell you that the y-intercept is going to be 0. So don't panic. It just means, there we go, y-intercept. Okay, next up I try and look for some x-intercepts. Okay, and that's where we let y equal 0. And so we're going to say 0 equals -1/3 x squared. And then I really like to get rid of these fractions, so let's divide by -1/3. What I do to the one side, I do to the other side. So I end up with x squared is equal to, if I have nothing and I divide it by -1/3, that's just 0. And then what's the square root of 0 is just 0. Okay, so this is a bit tricky because, grade 10s, we've ended up with the same point. So our x and y intercept is occurring at the same place. And so sometimes we end up with a little special case graph like this, and we just need to know how can we draw it when we can't quite get x and y intercepts. Okay, and so that's where we go to what is known as the table method, and I'm sure that your teacher would have shown you that when you were in grade 9. But we can literally draw a table method just for a couple of these values here. I always find you can probably just sub in -1, -2, and 1 and 2, and that will actually give you the coordinates. Okay, and you don't have to draw a table for it. You just need to know what you are doing. Okay, so we know that at 0, when x is 0, y is 0. That's what's happening here. Now let's work out what happens when x is equal to 1. So then we can use our fancy function notation, and we can say, well, what is f of 1? It's equal to -1/3 times 1 squared, which is just -1/3. So now when x is equal to 1, y is equal to -1/3. We can plot that point there. And then what you'll find is something very similar on the -1 side, because these things, this parabola is symmetrical about the y-axis. So if I were to sub in -1/3 and then -1, so what does this graph equal when x equals -1? Okay, what you'll notice is minus times a minus is a plus, and so we end up again with -1/3. So I can say, well, when x is -1, y is -1/3, and I can plot that point over there. Now let's do the same thing, but actually I'm going to let's skip the -2s and let's pop in the 3 and the -3. Okay, so f of 3. So in other words, when x is equal to 3, what does y equal to? We are really using this function notation to our advantage here. So -1/3 times by 3 squared. Okay, 3 squared gives me 9, and then 9 times by -1/3, that's going to be -3. So I can then plot that point, f of 3, when x is equal to 3, y is equal to -3. Let's plot a point there. Okay, and because, like I said, this is a symmetrical graph, f of -3, you're going to notice, is going to be the same. So -3 times -3 is going to give me 9. 9 times by -1/3 is going to give me -3. So there, when x equals -3, y equals -3. And so now I actually have enough points to plot this parabola. There we go. Okay, and then we label it. We said this was the graph of f that we needed to draw. And we can label a point or two along the way, but as long as your intercepts are labeled, that's generally the most important. So this was +3 and -3, and then let's label this one here, minus 3, and minus 3. Okay, so if ever you end up in a little bit of a sticky spot where you find, oh, my x and y intercepts are the same and I don't know what to do, remember that you can use what we used to use in grade 9, the table method. So you can choose a couple of x values and then substitute them into your equation to figure out what would the y value be when x equals this. And then you can plot it point by point, draw your graph, label your points. Alright, they may also ask us to determine the equation of a function. So like this one here, we've got a parabola. It's a sad parabola, so I can straight away see, that's going to be a negative a value. Okay, when they ask me to determine the equation, I always like to start off by writing down the equation, or the standard form. So y is equal to ax squared plus q is my standard form. And I can tell you straight away, that needs to be negative because this is a sad parabola. Okay, let's have a look at this information that they've given us, because I often need coordinates. So they've shown us here that the x-intercept is 2, so I can definitely put that in coordinate form. It's going to be 2 and 0. Remember, when y is equal to 0, we have an x-intercept. And then similarly, when x is equal to 0, we have a y-intercept. So there it's just in coordinate form, just in case we need that. Okay, what we know is that this q value is the y-intercept. So I can straight away substitute in that positive 4. So let's do that. Y is equal to ax squared plus 4. And now, in order to get the a value, let's substitute in one of these points. And it shouldn't matter which one, but I'm going to take 2 and 0 because we haven't used it yet. And so we're going to say 0 is equal to a times 2 squared plus 4. That ends up being 4a plus 4 equals 0. Take the 4 over, so minus 4 equals 4a. Let's divide both sides. And we end up with a equal to minus 1. Alright, that's great news, because then I can take it back into my equation. And I can say, well, therefore, y is equal to, instead of a now, minus 1 x squared plus 4. And remember, we said it does need to be a negative value to make this a sad parabola. So there we go. As long as you know what each variable represents, you can determine the equation of any function.